What's today's problem? Word subset. Let's do it. You are given two string arrays, words 1 and words 2. String B is a subset of a string A if every letter in B occurs in A, including multiplicity. What is that? For example, WRR is a subset of warrior but is not a subset of word. Okay, so the count of each letter should also match. A string A from words 1 is universal if for every string B in words 2. B is subset of A. Return an array of all universal strings in words 1. You may return the answer in any order. It's quite a difficult question. Quite a question. Question. Oh, let's see how we can understand this. We have like this list: Amazon, Apple, Facebook, Google LeetCode, and we have two words in this, E and O. So E is in Apple, is in Facebook, is in Google, is in LeetCode. O is in Facebook, Google, and LeetCode. So both of these strings are present in this. So this is our output. But what about the multiplicity, right? The word WRR, the two R's should match with okay, so there are three R's, so two are matching with these two, but okay, so if there was one more R in this would have been subset of this. I think that's a better assumption. Return an array of universal strings. So let's see what is the brute force approach here. Check if this is in each of these thing. So if it is not in any of this, we remove this object, right? And we go ahead. Now we check for O. O is not in this. We remove this and we keep everything else. And after that, we return the list. So that's one of the algorithms that is coming to my mind. The words of length 2 can also be something greater than 1. This is fairly easy because it's just 1. Now there are multiple things to handle here. Let's see. First thing is word subset, right, of a and another word. That's the first thing I should be able to figure it out, right? And if it is or if it is not, then I should remove it from our list. If not, remove from list. Do it for each word in words 2. Yeah, yeah. So these are the 3 things I need to do. And my daily checklist, I think I'm not gonna write it right now. Just going to directly jump onto coding. Okay, so that makes sense. So let's see about the characters. All strings in word 1 are unique. Okay, that's a good thing. And only lowercase English letters. That's another good thing. Now, how can I? This is the main question. Is the word subset of another word? So let's define is subset. Self word 1, word 2. Somehow I need to check if word 2 is subset of word 1, right? So let's see how we can do that. String B is a subset of string A if every letter in B occurs in A, including multiplicity. This is kind of confusing because there are 2 R's in this, there are 3 R's in this, and still this is subset of this but not this. That's the only thing. If I wanted just 2 R's match with 2 R's, that would have been easy. I have to match it with 2 or more. I think that's the meaning of multiplicity. Yeah, so if I'm not clear on that, then that's a problem. Is there any other edge case? Let's not think about this. Let's think about this only. So what can I do? I can create 2 maps and map of word 2, map of word 1, right? And then for each yeah, so that makes sense, right? So let's say I have a map for this word, which will be W is equal to 1, R is equal to 2, and I will have map for this W is equal to 1, R is equal to 3, A is equal to 1, I is 1, O1, and for each letter I will check if the multiplicity and the word is exist in that map, in this map. If everything matches, then it is a subset. Yeah, I think that this should work. I think this should work. So let's do that. Let's say word 1 map word2 map. These are the two maps. So let's do two loops for character in word1. Let's see, word1 dot map dot set default character value equal to 0, and then I will increment this of character plus equal to 1, and I think I should do this for word2 as well. Okay, word2 okay, and let's just call this like self dot is subset, call with this, and I'm just trying to print it and check it. So let's print word map and just to make sure I'm doing it correctly, because I'm not sure if how set default works. Yeah, so it's working fine. Now word2 is our smaller string, right? So let's check for key comma value in word2 map dot items, right? So I will return false from here if there is not key or the value is less than in word1 map. So that's what I'm going to do. So if key not in word1 underscore map, or if it is not in word map, then return false, or if it is present in word map but it's less than the value, key is less than v, if it is equal to or greater than, then it's fine. If that's the case, then return false, otherwise return true, right? Let's see, print how this works. So it printed true for this. Let's change this to word, it should print false. Yeah, so this function is working correctly now. This thing is done. Now I have to check if it is not the subset, then I have to remove it from the original one, or maybe just or just add, if it is subset then add it to the list and replace the word list. Yeah, that's I can do that. I think I can do that. So let's do that. um so so for so for each word in word 2, so let's see. So for each word in word 2, words 2, I have to check if this is subset of I have to check it in everything, right? Yeah. uh I think this is a brute force and this is quite a expensive thing, but I'm still gonna just go with the brute force approach. So let's see. So we have word, and then let's see, temporary word 1 is equal to an empty list, and then for each let's call this as word 2. For each word 1 in words 1, right? For each word 1 in words 1, check if self dot subset is subset word 1 comma word 2. If it is true, then temporary word 1 dot append word 1. And we are going to do it for each word in words 1. Once everything is done, we have to change this to word 1. So we have to update our word 1. So words 1, this list is going to be updated by this list. So what is going to happen in this loop is I'm starting to iterate over each word, okay, and I'm creating a temporary list, and then in that I'm iterating over all these words, okay, and I'm checking if word 1 and word 2, if it is subset. If it is subset, only then add it to this list. So in our case, Amazon is not subset of E. Then I will check for Apple, I will check for Facebook, Google, leetcode. So all these will be added to this list, okay, and then our will update the word 1 with this list, and then we'll go for O, and Apple will be not be added to this list, and uh, and these all will be added to our list because O is present in each of them. Now once we have done that, our word 1 will have only filtered out elements, so we can return words 1. I think this should work. Let's see first if it is working. Okay, it worked for at least for first example. Let's see for this. Let's take this example. Okay, let's take warrior, let's take word, and let's remove this, let's have just a warrior in here. Okay, I think this has to be list, right? This should be the list. Yeah. And okay, so accepted. I think there is a possibility of a time limited exceeded error, but let's see. At least brute force is working, but TLE will not work because time complexity wise it's too much. Again, I can calculate the word maps of these ones and these ones, right? And that could improve because this is like this is yeah. So what I'm thinking is to improve. I'm not gonna do that. I think this is like brute force solution, and it will work. But what I can do, I'm just gonna say is remove this part, okay, and create a function, right, which returns you the word map, okay, and save it in another map globally. Let's say for this word, uh, let's say for this word, what I'm going to do is create a map which is another map of each letter and its value. So D as 1, comma X as 2, something like that, right? So right now we are calculating this every time. That's going to be improved. Next time I will get in subset, this function will change, like word map 1 will be get map from the global map of this word and get map of global map of this word. So yeah, and then these two things will not be required multiple times, only this will be required. So that will improve the performance. And yeah, I think that should be fine. Let's see what is the actual solution. Reduce to single word in B. Okay, now that's kind of interesting. I think you guys can read the solution. Maybe not. So let me provide you with the solution. It's going to be a big video, 30 minutes. So let's read it completely. If B is a subset of A, then say A is superset of B. True. Also say n of a word is the count of number of a's in the word. When we check whether a word a in a is a superset of word b, in we are individually checking the count of letters. Yeah, that's what I'm doing. That for each letter we have something like this I don't understand. Now if we check whether a word a is superset of all words b, we will check each letter in I. That's not making sense. Let's take an example. When checking whether warrior is a superset of words b, we can combine these words in b to form a maximum word a r r o w that has a maximum count of every letter in each word in b. Reduce b to single word b max as described above, then compare the count of letters between words a and b max. Okay, time complexity a plus b, where a and b is the total amount of information in a and b respectively. Space complexity a dot length b dot length. Now let's take this code. Let's just copy it and paste it. And they have changed this a and b, so I have to change this. And let's try to run and see. Okay, that's working. So let's see what is happening. Def count word answer. Okay, instead of map they are using character array of 26. For letter in word, ORD of letter -1 plus 1. Okay, and that's the array we get. Okay, then we have a b max. Now what we are doing, this is kind of confusing. For I, in enumerate count of b, so for each word in b, what I'm going to do is I'm going to get an array of b, and for each index at this position I am saving the maximum of that of so far of that count or the new count. Okay, that's fine. And then I'm checking, and then for each a I don't know what this is all. I am going to take Hmm. So what this is doing is calculating this array for each word in A now, and then comparing it with B max. And if each letter is greater than or equal to letter in B max, only then add. If it is missing, don't add. If it is less than, don't add. And that's our answer. Yeah, what kind of makes sense. So, so in short, what the solution is, calculate the frequency array of each word in B, okay? And for this, the array will have like, let's say, W1 and R2, okay? And then for this, it will say W1, which is equal to, so it doesn't matter, and A1, okay? And for this, it will say O1 and R1. But but in our B max we might have R2, which is required, right? So that's what we are doing. So we are calculating the B max, like we were saving each map differently, but we just want to save the maximum of each word per count, and we are saving it in this. And then we don't have to compare each word with each word, we just have to compare this with each word in the word list of one. So kind of a mouthful, kind of a difficult question for me, but yeah, somehow I figured it, like I understand the solution. My brute force approach would have worked, I would have optimized it a bit, but this is better, this is nice. So yeah, thanks. Bye bye.